Hello and welcome to Astronomy Daily, your cosmic connection to the universe's latest developments. I'm Anna, and today we've got a stellar lineup of space stories that showcase both the wonder and ambition of humanity's quest to understand the cosmos. Coming up, we'll explore a truly cosmic miracle as the James Webb Space Telescope breaks its own record by discovering the earliest galaxy ever observed. We'll also look at Europe's daring plan to land a spacecraft on the infamous asteroid Apophis during its close approach to Earth in 2029. Then we'll dive into the latest chapter of SpaceX's Starship Saga. And finally, we'll unravel the mystery surrounding one of the night sky's most recognizable stars, Betelgeuse, as astronomers search for evidence of a hidden companion that might explain its puzzling behavior. Strap in for a journey across time and space as we explore these fascinating developments right here on Astronomy Daily. Let's kick things off today with a pretty important discovery. The James Webb Space Telescope continues to rewrite the astronomical record books with its latest discovery. JWST has detected what scientists are calling the mother of all early galaxies, fittingly designated MAM Z14. This remarkable cosmic find existed just 280 million years after the Big Bang, making it the earliest and most distant galaxy ever observed by humanity. To put this time frame into perspective, sharks have been swimming in Earth's oceans for longer than the universe had even existed when this galaxy was forming. MAM Z14 breaks the previous record by about 20 million years, which might not sound like much, but represents a significant step closer to observing the very dawn of galaxy formation. What's particularly fascinating about this discovery is that the JWST wasn't actually expected to find galaxies from this early epoch, at least not at this stage of its mission. Scientists have now identified over 100 more relatively bright galaxies in the very early universe than were predicted based on pre-JWST observations, challenging our understanding of how quickly the cosmos developed. The research team was able to determine that MAM Z14 is approximately 50 times smaller than our Milky Way. Perhaps most intriguing is the detection of elements like nitrogen and carbon within this ancient galaxy. This is surprising because the very earliest galaxies should primarily contain only the simplest elements, hydrogen and helium. The presence of these heavier elements, which astronomers somewhat confusingly call metals, indicates that MAM Z14 isn't actually among the very first objects formed in the universe. These heavier elements are created inside stars and then dispersed through supernova explosions, suggesting there must be even earlier galaxies out there waiting to be discovered. Perhaps the true first generation that contained only hydrogen and helium. Researchers are confident that JWST is up to the task of pushing these boundaries even further. As one scientist put it, they would not be surprised if we find galaxies at redshift 15 or 16, taking us even closer to witnessing the universe's earliest moments. This discovery is another testament to the Webb telescope's revolutionary capabilities, allowing us to peer further back in cosmic time than ever before and reshape our understanding of how the universe evolved from its earliest moments. Next today. Once feared as a potential threat to Earth, Asteroid Apophis is now presenting space agencies with a rare opportunity for exploration. The European Space Agency is actively preparing its Ramses mission, which stands for Rapid Apophis Mission for Space Safety, for a 2028 launch to coincide with Apophis's very close but safe flyby of our planet on April 13, 2029. This 1,100-foot wide space rock will pass within about 20,000 miles of Earth, closer than many of our artificial satellites. The Ramses mission aims to conduct detailed before and after analysis of the asteroid, studying its surface characteristics, composition, and orbit. Scientists are particularly interested in how Earth's gravitational pull might trigger tidal forces in Apophis, potentially altering its surface and interior structure during the close approach. In an exciting development, ESA has now selected Spanish company MAM to lead the development of a second CubeSat that will attempt something extraordinarily challenging, landing on Apophis. As Paulo Martino, the Ramses project manager, explained, landing on an asteroid presents unique difficulties. The irregular shape and unpredictable surface properties make it hard to identify stable landing sites, while the asteroid's extremely weak gravity creates a risk that the lander could simply bounce off and drift away into space. The main Ramses spacecraft will be a modified version of ESA's Hera probe, which is currently on its way to study the binary asteroid Didymos, where NASA's DART mission successfully impacted in 2022. However, despite the momentum behind this mission, it still requires ESA member states to formally commit funding at the agency's Ministerial Council meeting this November. NASA is also considering repurposing its shelved Janus spacecraft for an Apophis mission, though budget constraints have complicated these plans. The good news is that NASA's OSIRIS-APEX mission, the extended mission of the spacecraft that successfully returned samples from asteroid Bennu, will arrive at Apophis about a month after its Earth flyby. Additionally, Japan's Destiny Plus mission, which faced delays, has now been rescheduled for a 2028 launch and will make a flyby of Apophis on its journey to study asteroid Phaethon. Scientists worldwide are emphasizing the importance of international collaboration to make the most of this rare opportunity that Apophis presents for advancing our planetary defense knowledge. And now, a quick SpaceX update. The Federal Aviation Administration has now stepped in following the 9th test flight of SpaceX's massive Starship rocket, requiring the company to investigate what went wrong. Interestingly, the FAA's investigation is narrowly focused on just one part of the mishap, the loss of the Starship upper stage, which failed to complete its planned trajectory as designed. Despite both stages of the vehicle meeting explosive ends, the FAA clarified that the destruction of the Super Heavy booster was actually covered by what they called approved test-induced damage exceptions that SpaceX had requested prior to launch. In other words, some level of damage or destruction to the booster was anticipated and approved as part of the experimental nature of the test. Flight 9, which launched on May 27th from SpaceX's Starbase facility in South Texas, represented a significant milestone as the first ever reuse of a Super Heavy booster. This particular booster had previously flown during January's Flight 7 mission, where it not only completed its engine burn successfully, but also made a dramatic return to Starbase, where it was caught by the launch tower's mechanical arms, nicknamed the chopsticks. For Flight 9, SpaceX took a more experimental approach with the booster. Rather than attempting another tower catch, they conducted various tests, including bringing the booster down at a higher angle of attack to increase atmospheric drag. The plan called for a hard splashdown in the Gulf of Mexico, but things didn't go as intended. Contact with the booster was lost shortly after it began its landing burn, approximately 6 minutes after launch, when it experienced what SpaceX euphemistically described as a rapid, unscheduled disassembly. The Starship upper stage faced even greater difficulties. It was supposed to make a controlled splashdown in the Indian Ocean off Western Australia about 65 minutes after launch. However, an attitude control error prevented the vehicle from achieving the proper orientation for re-entry. Following automated safety protocols, Starship vented its remaining pressure to create the safest possible conditions, but contact was lost about 46 minutes into the flight. Despite these failures, the mission still showed progress compared to previous flights where the upper stage was lost within just 10 minutes of liftoff. The FAA noted that there were no reports of injuries or damage to public property, and the impact on commercial flights was minimal. Just one flight diverted and another briefly held for 24 minutes. Betelgeuse, one of the most recognizable stars in our night sky, has long captivated astronomers with its unpredictable behavior. This massive red supergiant in the constellation, Orion, sits about 640 light-years from Earth and is nearing the end of its stellar life, destined to eventually explode as a supernova. At more than 700 times the size of our sun, it's truly a cosmic giant. What's particularly intriguing about Betelgeuse is its peculiar brightness variations. You might remember the excitement in late 2019 when it dimmed dramatically, leading to speculation that a supernova might be imminent. That event turned out to be just a massive dust cloud temporarily blocking its light, but it highlighted the volatile nature of this dying star. Now, astronomers are exploring a fascinating possibility. Betelgeuse might not be alone. About 1/3 of stars similar to Betelgeuse display what scientists call long secondary periods, or LSPs, which are extended brightness fluctuations that have puzzled researchers for decades. While various explanations have been proposed, from internal pulsations to dust formation, evidence is increasingly pointing toward a hidden companion star. The current theory suggests a low-mass companion, somewhere between half to twice the mass of our Sun, might be orbiting Betelgeuse every 2,100 days. That's roughly 6 years, at a distance comparable to Saturn's orbit around our Sun. This companion wouldn't dramatically alter Betelgeuse's evolutionary path, but it could influence the supergiant through tidal forces and interactions with stellar winds. This hypothesis also helps explain other mysteries, like Betelgeuse's unusually fast rotation speed of 5 to 15 kilometers per second, which could result from tidal interactions with this orbiting companion. The theory even accounts for the observed 36-year cycle in both brightness and radial velocity patterns that have long confounded astronomers. Despite targeted searches using the Hubble Space Telescope's STIS spectrograph, this potential companion remains elusive. Researchers timed their observations for when the companion would be most visible in far ultraviolet light, but no clear signals were detected. This doesn't rule out its existence. The companion may simply be too small and cool to be detected amid Betelgeuse's overwhelming brightness. The search continues because finding this hidden partner isn't just scientific curiosity. It could significantly enhance our understanding of how massive stars evolve and eventually die in spectacular supernova explosions. That's all for today's episode of Astronomy Daily. What an incredible journey through the cosmos we've had. From the discovery of MAM Z14 to Europe's ambitious plans to land on Asteroid Apophis during its 2029 flyby of Earth. We've also examined SpaceX's ongoing Starship development with its recent Flight 9 mishap, and explored the intriguing possibility that Betelgeuse, one of our night sky's most famous stars, might have a hidden stellar companion. The universe continues to surprise us with each new discovery, reminding us just how vast and mysterious our cosmic neighborhood truly is. I've been your host, Anna, and I want to thank you for joining me on this cosmic journey. If you enjoyed today's episode, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and access all our back episodes. You'll never miss a moment of astronomical discovery. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Until next time, keep looking up. The universe is waiting to be discovered.